Example 3, here we're going to sketch a graph of a rational function. So we have our function f of x is equal to 3x over x squared plus x minus 2. So if we follow our 7-step guideline, we first need to simplify our function. So we're going to make this f of x is equal to 3x over x squared plus x. Oh my gosh. Let me restart that. We're going to factor this. So factors of negative 2 add to a 1, x plus 2, and x minus 1. So there it's simplified. So let's go through our steps. The first step is we need to find our y-intercept. So your y-intercept is at, well, you plug a 0 in for everything. So you have a 0 on top divided by negative 2. Well, 0 over anything is just 0. So your y-intercept is at 0. For the next part, after we simplify, then we need to find our zeros of our function. So our zeros of our function is where you set the top equal to 0. So we're going to set 3x equal to 0, and if you divide both sides by 3, you get 0. So our x-intercept and our y-intercept end up being at the same point at your origin. Interesting. Vertical asymptote. Well, that's where you're going to set your denominator equal to 0, and we have 2 of these, so it looks like we're going to have 2 vertical asymptotes. So you set x equals a negative 2, x equals 1. We need to plot these. There's 1. Here is another. There we go. So there's your 2 vertical asymptotes. Now we need to find our horizontal asymptote. Anybody else get annoyed by those? Yeah. All right, well, you look at your degrees to find your horizontal asymptote. You look at the degrees. Your leading term on top has a 1, leading term on the bottom has a 2. So since the top, your n, is less than the degree on the bottom, then you're going to have y equals 0. Now notice you have 2 vertical asymptotes here. Basically what you've done is you do not have a vertical asymptote that goes through in between these 2 vertical asymptotes. So you don't have a horizontal asymptote that goes through there. So your horizontal asymptote actually goes on the outside here. So the last thing we have to do is we have to make a table of values and sketch our graph. So because we have 3 different sections here, we need to put some extra points in. So we need to choose 2 points to the left of our first vertical asymptote. So let's plug in a negative 4 and a negative 3. So let's plug in negative 4 first. Well, it's going to give us a negative 12 on top divided by, and you can plug it into your original function or your simplified function, but you are going to get a negative 12 on top. And if I plug a negative 4 in my factored, I have a negative 2 times a negative 5, which is a negative 12 over 10, or a negative 6/5, which is also known as a negative 1.2. So if I go back 4, up 1.2, here's a point. If I go back 3, plug in a negative 3, that gives us negative 9 over, on the bottom you have negative 1 times a negative 4, which is a negative 9/4, or some of you may know that to be a negative 2.25. So back 3 up 2.25 is right around here. So we can actually kind of draw this little sketch in here. So we need some points in between our 2 vertical asymptotes. We already have 1, so let's plug in negative 1. Let's see what that does. So if we plug in a negative 1 to our function, that gives us a negative 3 on top. And on the bottom, you have a 1 times negative 2. So you get a 3/2 3 halves is a 1.5. So back 1, up 1.5. This isn't really showing us much, but you notice here in the middle we don't have a horizontal asymptote. Typically your graph is going to be going down from left to right or going up from left to right. In this case, we should probably double check by plugging a couple more points in. So if we plug in like a -1/2, or you plug in like a 1/2, your graph should be going somewhat similar like this, down from left to right, like so. And you should have a nice pretty graph like this. Now the only thing that's left is to put another couple points out to the right. So we're going to plug in a 2 and plug in a 3. So if you plug in a 2, you're going to get y equals a 6 on top, and then you're going to get a 4 times a 1 on the bottom, so you get 6/4, also known as 3 halves, which is a 1.5. So you go over 2, up 1.5. Plug a 3 in, y gives you a 9 over 5 times 2, or that's a 9/10, or a 0.9. So you go over 3, up 0.9. You'll notice this graph is going to be getting closer to your asymptotes as you go up. It's going to get closer to your vertical asymptote. And as you go down, it's going to get closer to your horizontal asymptote. So there is your graph. We need to state our domain. So for your domain, remember it's going to be all real numbers except whatever makes your denominator equal to 0. So we're going to say all real numbers except x can't be equal to -2 or a +1. So there's your graph, there's your domain.